Greetings, students. I hope everyone is doing well. I have seen you around, so I'm happy to be here with you this summer as we prepare for some SAT prep. I'm excited to welcome you to our 2021 UB STEM session. This is a part two, which continues from our session that we will have with each other during the Upward Bound STEM week, and then this is your part two. So prior to today, we have discussed your top 15 hardest problems from the SAT. So numbers 1 through 5 I covered already. Today we're going to do in this lesson numbers 6 through 10. So there's a top 15. I'm going to cover the next 5, and I'm doing it in increments of 5 just because it's a little intense. So I don't want to overwhelm you in one session. You will see that I will ask you to pause the video and to work out the problem on your own. Then I'll go through my explanation, and that's just to make sure that you have time to process it, to read over the problem, and then when I'm working through it, hopefully I answer any questions that you may have. If there are any issues, by all means, feel free to email me at aull@midlandstech.edu, or you can email me directly through my company, alleducationalservices@gmail.com. Okay. Again, this video is directly for the Upward Bound students at Midlands Technical College. So if you're watching this and you're not a part of that entity and you would like to be a part of it, feel free to contact me and I will put you in contact with the director of the program. Thank you so much for checking this out, and let's begin. Please make sure you have a calculator and a pencil. There's a part where you can't use the calculator for the SAT, and then there's another portion where you can. So please make sure you have those materials, a calculator, a pencil or pen, and writing paper of some sort that you can use to work out your problems. All righty, let's get started with number 6. Okay, I've shared my screen and you can see number 6 on our list today. And that question reads, in triangle ABC, the measure of angle B is 90 degrees. BC is equal to 16 and AC is equal to 20. Triangle DEF is similar to triangle ABC, where vertices D, E, and F correspond to vertices A, B, C, respectively. Each side of triangle DEF is 1/3 the length of the corresponding side of triangle ABC. What is the value of sine F? Okay, and that's a lot to digest, right? So we're going to take this into segments, okay? And that's the best way I can tell you to take one of the harder questions. And for those of you who are just joining us, if you haven't taken a pre-SAT or taken the SAT once just to see where you are, please look for Khan Academy. They have some practice tests that you can try just to kind of see where you are. And that way you will know whether or not you need to be working on these, which are more difficult for the higher end of the math score, or maybe you need to start with the beginning levels and work your way up, okay? All right, now I'm a visual learner, so if you are, you're more than welcome to draw a triangle for triangle ABC. So I'm gonna pause and let you draw that while I draw it, then I come right back. And I'm gonna be pausing in between. It's gonna help cut out the length of the video. So you will see that happening. And then when I unpause, you'll see my work. So let's go ahead and sketch this triangle. Okay, hopefully you paused. Here we go. We have triangle ABC. We know that B is at a right angle, so I have that there. We have our similar triangle DEF, which is also a right triangle, and it corresponds respectively. And it's not drawing a scale, of course not, right? But when we're doing our math, you just want to jot it down so you can visually see how they correspond to one another. All right, so triangle ABC is a right triangle. We have its angle at B, which lets us know that AC, our longer side, is going to be our hypotenuse. And I'm just going to write HYP for that, okay? So that's your hypotenuse of the triangle ABC. And with that being the hypotenuse, it lets us know that AB and BC are our legs. And I hope you can see where I'm going with this. All right, these are our legs, okay? Since we have our legs and our hypotenuse, we can use something called, what is it? There you go. Your Pythagorean theorem. Good. Hopefully you said it. Or you was like, oh, I can't remember, but I know it. All right, I'm going to make sure I spell this right, so I'm going to copy it. Your Pythagorean theorem. If you're not sure what that is, please review some of your studies. That should be an N. It looks like an M. There you go. Your Pythagorean theorem. And what does that say? A squared plus B squared equals C squared. Got that? All right, finish jotting that down for me. And we're going to use the information from our triangle to figure out what our missing side is. And while you're doing that, let's go back and look at our problem. We know that BC, which is our leg here, is going to be 16. I'm going to change colors. So leg BC is 16. That's our measure. We don't know if it's centimeters, inches, it doesn't matter. AC is 20. So this side is 20. So we're looking for the leg AB. You can put that as your X. Now, we can solve for this by using the squares of each and then take the square root at the end. I want to show you another way to do it. I'm going to jump straight into what AB is equal to. And if you are lost in this part, then do not follow Miss All. I want you to do it your way, okay? And I'm going to show you how you can manipulate it to solve for AB. So you solve it your way, if this is the way you solve it. And then I'm going to solve for AB and we'll come right back and let's see if you have it. So pause the video right now so you don't see my work. And I'll be with you momentarily. All righty, students, I got it? Okay, keep working if you don't. I'm gonna go ahead and show you how I solved it. Same process, but I isolated for AB. And if I'm solving for the leg AB, it's gonna be equal to the square root of 20 squared minus 16 squared. And I do all that math and we end up with AB equaling 12. So X is gonna be equal to 12. Now that's the first part of the question. Now we have to get to where we find the value of sine F, because this is the actual question. What is the value of sine F? Not what is the value of the leg AB, okay? So now we gotta move on to sine F. Let's go for it. And I am going to scroll down so we can work through that. All right, now to do that, if I can get rid of this red line, maybe. There we go. All right, let's do the second part of the problem, right? Since triangle DEF is similar to triangle ABC, because we drew it, right? The vertex is going to be F. F is corresponding to the vertex C. So let me show you the triangle again. We did it together. We're looking at F, right? F is going to correspond to C, okay? That's what the problem tells us. Now, since the vertex F corresponds to vertex C, the measure of angle F is going to be equal to the measure of angle C, right? That's what corresponding means. Therefore, let's scroll down a little bit. That lets us know that sine F is equal to sine C. I didn't let you figure that on your own. If you did, that's great. I just didn't want you to get lost in the text, okay? So because we have corresponding angles, which means they're equivalent, we know that sine F is going to be equal to sine C. Now, how do I figure out sine F? You guys remember the formula for that? Sine is going to be, pause it if you know it. If not, I don't want you to get stuck. So let's do it. Sine F is going to be equal to, do you remember opposite over hypotenuse? Well, let's see, opposite side. I'll spell it all the way out, just in case you haven't heard of this before, or maybe in a while. Opposite side over hypotenuse. So if you're looking at this and you're like, oh my gosh, I don't remember where this came from, please make sure you take a math class, especially in high school. Curriculums change depending on where you are. So I highly encourage you to take a math class while you're preparing for your SAT, just to keep things fresh in your mind. All right, remember we talked about our hypotenuse and our opposite side. So this came from my picture, which is why I say if you're a visual person, which most of you probably are, make sure you're looking at the visual here. Our hypotenuse is AC and our leg is AB, the opposite side of that angle. All right, so opposite over hypotenuse, and then we just plug in those numbers. So what was the value of AB? Remember, we solved for that, right? It was 12. That's why we needed that side, okay? We didn't need the other, we didn't need BC, we needed AB, okay? So that's why you had to figure that out. So we got 12 over, and AC was given to us. We can scroll back up and see what that was. AC is 20. And then this part we're all familiar with. You know how to simplify fractions. Divide both of these by, let's see, the largest number is going to be 4. So divided by 4 is 3. 20 divided by 4 is 5. You got it. All right. So sine F is equal to 3/5. And usually you're going to see it as an exact answer. Remember, fractions are exact. Decimals aren't always. So if you see it as a decimal, this one terminates, which is good, into 0.610. All right, which is perfect. If it doesn't simplify into an exact decimal, choose the fraction because fractions are exact. Okay. All right. Congratulations. You just finished number 6. And it is a little more challenging, right? It's not your simple SAT problem. It is a little more challenging. Okay, so we're going to move forward to number 7. All right, students, let's go to the next challenge, okay? Question number 7, and you will have graphs on or charts or visuals on your SAT. This particular one deals with right and left-handedness, okay? The incomplete table above summarizes the number of left-handed students and right-handed students by gender for the 8th grade students at Kiesel Middle School. And that could be Kiesel Middle School. Remember when we're reading, especially during math, we're not worried about what the name says. If you don't understand what it is, you can call it K Middle School, right? That's not what's important. There are 5 times as many right-handed female students as there are left-handed female students. There are 9 times as many right-handed male students as there are left-handed male students. If there is a total of 18 left-handed students and 122 right-handed students in the school, which of the following is the closest to the probability that a right-handed student selected at random is female? And we're going to assume that none of the 8th grade students are both right-handed and left-handed, okay? Because that is possible. So everybody is just one choice, left or right-handed. All right, pause for a moment and let's read over that again. I want you to read over it yourself, and then we'll come back and we'll figure out how we're going to solve this, okay? All right, I gave you enough time. Hopefully you went through and found some important information, like things you should remember in order to solve the problem. Now, in order to solve this, we're going to have to create 2 equations, and we're going to use the variables X and Y, and we're going to pull the information that we were given from the problem. So I'm going to get my pen ready. All right, so let's see what we have. X, let's let that be the number of left-handed female students. And we can let Y be the number of left-handed male students. So left-handed female, we said would be X. I'm just gonna write it here somewhere. You just gotta make sure you know what your variables mean. And I'm just gonna do LH for left-handed, okay? And I can write out female. And then we're gonna let Y be, what did I say that was? Right, left-handed male students, okay? I'm not gonna write students because we all know that they're students. What's most important is the gender that we're representing and that we're representing left, not right, okay? All right, now I'm pausing. I'm hoping that you're thinking out loud with me and you're talking back to me, right? So talk back to me. All right, let's see what we have. We're gonna use the information given in the problem. The number of right-handed female students will be 5X, and the number of right-handed male students would be 9Y. Now, why is that? Why do we say we're going to let that be compared to the X and Y? So go back to your word problem, okay? In our word problem, I wanna highlight this. It says there are 5 times as many right-handed students as there are left-handed female students, right? So we're basing our right hands off of our left hands. So here's what that looks like. Since we're comparing them, we have X plus Y. And how many left-handed students all together? 18. So I'm gonna pull that number. And then since X was female, 5 times X for female. All right. And then how many was the right-handed male? You guys remember? Let's find it. All right, 9 times as many right-handed male students as there are left-handed male students, okay? So since we are comparing right hand based off of the left hand, we're gonna use 9 times the number of left hands. And then what was the total number of right-handed? You guys remember? Go back to our chart. 122, good. All right, so let's do 122 here. Perfecto. We have a system of equations. You remember these? Love these. All right. Since the total number of left hand is 18, the total number 120, we have our system of equations complete. And we're going to solve the system of equations. Now I want you to pause, because at this moment, I want you to go ahead and finish the problem. System of equations, use it. Remember, there's more than one way to solve. You can use your addition method to cancel. You can use your substitution method to solve. And since you have 2 options, I want you to use whichever one you're comfortable with, okay? Now I've been doing math a while, right? So I can do both of them, but you may not be comfortable with both. The good thing about the SAT is it doesn't tell you, like your classroom teacher would say, use this particular method. The SAT test does not give you a specific method to use. So you use whichever one's going to yield you the right answer, because that's what we want. All right, so I'm going to pause my recording. I'm going to work it out myself, and you pause now, and I'll see you when I come back. All righty, so I solved using substitution, and I changed my first equation, right? Because it's already singular units. So I either can use X is equal to 18 minus Y, or Y is equal to 18 minus X. Your choice. I chose to use X and substitute it in. So I substituted for X, solved. And when you solve for Y, you end up with Y equals 18. All right. Hopefully you've done the first letter, first variable. You may have solved for X first or Y. I'm going to solve for X next. So go ahead and pause this recording and let's make sure you have your X. I'm going to work on X now. All right, students, did you get 10 for X? Hopefully so. Awesome, awesome. If not, please find your mistake so that way we can figure out what went wrong. And you can pause and go back. Remember, whenever you get ready to solve for the second variable, all you do is plug it back in. All right, we already had the equation x is equal to 18 minus y. We just needed to know what y was. So once we figured out y was 8, substitute it back in. 18 minus 8 is 10. So x is 10. All right, we're not done. Let's go back. We're looking for which of the following is the closest probability that a right-handed student selected at random is female, okay? So we have our multiple choice options. We gotta go back and look for right-handed female. Do you remember what female was represented with? Yes, female was our X, all right? So we're gonna look to see what our X looks like, but we need right-handed. And remember, the right-handed part was represented by, there you go, 5x. So we're going to pull out, see how important it is to know like what you labeled, what it represents, vitally important. Or we would have been lost and wouldn't have known, well, is it the 5x or the 9y? Okay, so we got 5 times x. So let's figure out what that is. All right, 5 times x is going to be 5 times 10. Easy enough, 50. And that's our right-handed females. But that's out of how many students? How many were right-handed? Do you remember? What was the total? Right-handed total? Right, good, 122. All right, so right-handed female. I'm just gonna put F for female. Right-handed female is 5x, which is 5 times 10, which is 50 over 122. This is our final answer. We need it as a probability, so we're gonna plug it in our calculators real quick. 50 divided by 122 is gonna give me, I got 0.409. And if you round that up, that 8, here, I'll write it all out. 0.98. We're rounding up, right? So we end up with 0.410 as our final answer. And I think that was A. All right. Remember, if you round up based off of the neighbor. If it's 5 or more, you go up. If it's 4 or less, it stays the same. So A is our final answer. Very good. Whew. All right, that was a good bit of work. If you need a break, take a moment, grab a snack, grab a beverage. I have my water, and then we're gonna move on to number 8. Good job, students, so far. Hang in there. We're doing hard stuff today. This is like top-notch hard SAT. If you're getting through this smoothly, then you're gonna soar on that test. All right, I'll see you back for number 8. And I'm gonna pause, so you can pause right here, and then I'll be back. All right, welcome back. Hopefully you're rested. Give yourself a little brain break. Let's do questions 8 and 9. Now, it is not uncommon for the SAT to have questions that are one source of information for multiple problems. So we're going to work on that a little bit and see how that integrates with math. You see it quite often in reading where you have a passage and several questions. But for this one, for math, let's see how that might look. All right, so I mean, this is for number 8 and 9. So let's do number 8 first. The basic information is, if shoppers enter a store at an average rate of R shoppers per minute, and each stays in the store for an average time of T minutes, the average number of shoppers in the store, represented by the variable N, at any one time is given by the formula N equals RT. This relationship is known as Little's Law, okay? All right, the owner of the Good Deal store estimates that during business hours, an average of 3 shoppers per minute enter the store, and that each of them stays an average of 15 minutes. The store owner uses Little's Law to estimate that there are 45 shoppers in the store at any time. Number 8. Little's Law can be applied to any part of the store, such as a particular department or the checkout line. The store owner determines that during business hours, approximately 84 shoppers per hour make a purchase, and each of these shoppers spend an average of 5 minutes in the checkout line. At any time during business hours, about how many shoppers on average are waiting in the checkout line to make a purchase at the Good Deals store? Now, that was a mouthful. I'm not going to read it twice just because I'm recording, but I am going to pause real quick and I'm going to let you read it, digest it, and then we'll come back and work it out. All right, so take a moment and reread this. You can pause your video now. Okay, did you get that? It was definitely a mouthful. All right, let's dissect this and see what it's telling us. So, since the question states that Little's Law can be applied to any single part of the store, for example, just the checkout line, because that's what we're looking for, then the average number of shoppers in the checkout line at any time is N. We're going to write that again. Here's your equation. N is going to be equal to, do you remember what it was? R, lowercase r, times T. R is the number of shoppers entering the checkout line per minute. And I'm going to write here, R is going to be shoppers per minute. And then we have T. And T is the average number of minutes each shopper spends in the checkout line. I'm going to abbreviate average. I'm going to abbreviate minutes. Okay, so R is the number of shoppers entering the checkout line, all right? And let me put that here, entering line, because there's a difference between entering and then how long you have to stay in that line, right? So the number of shoppers per minute that enter the line, and then the average number of minutes they spend in that checkout line. I hope that makes sense, right? People come to the line and you have to wait in line, right? We're all familiar with that if you've ever been to a store. All right, so now let's look at the information given. Since 84 shoppers per hour make a purchase, then 84 shoppers per hour have to enter the checkout line, right? Because the only way to make a purchase is to go through the line, all right? So we got 84 shoppers per hour. Ooh, per hour? Now that's different because we only have, and it's right here, 84 shoppers per hour, but we're using minutes. We got to do some converting. All right, you guys with me? Because that's not the same unit of measure. That won't work. All right, so let's see how can we change that. In order to convert it to the number of shoppers per minute, so that we can actually use the T equals 5, let's see, there's 60 minutes in 1 hour, and we're given 84 shoppers per hour. Okay, I'm gonna just write all that out. We have 84 shoppers per hour, and we know that there's 60 minutes in an hour. So we're going to convert that really quickly in our calculators, and you're going to end up with, got it? Type it, type it, type it. Okay, I have 1.4. And that number represents shoppers. There we go. Shoppers per minute. Right? So we're going to convert it. We had to convert because there's no way to solve it without changing that. Okay, so now we can use our information. All right, so using the given formula, we're going to use R, which is what we found, 1.4. Got that? And then what was our T? Can you pull it? Gave it to us. 5 minutes. All right. And all we have to do then, so not a very complex math problem, but you do have to dig out the information. So just some conversion. All right, so now that we've converted, we have our information, we're just going to plug in 1.4 times 5. Calculate that real quick. All right, tell me what you got. All right, Miss All has 7. Did you get that? All righty, but what does that mean? Can you interpret what that means? All right, the average number of shoppers, which is represented by the variable n, in the checkout line at any time during business hours is 7. It's a pretty long checkout line, right? Hopefully the cashiers work fast. Here you go. All righty. 7 was our final answer. Good job. Again, not as much intensity on the math part, but you did have to do a lot of processing to figure out what goes where, what everything means. And that is rather challenging, especially when you're working under a time constraint. All right, good job. That was number 8. Let's go to number 9, where we have to use the same start off information, but there's a different problem. I'm gonna pause real quick and pull that up for you. Number 9, take a moment if you need to. I'll be right back. All right, welcome back. Remember I said we're only doing 5 in this set, right? So we did 6, 7, 8, 3 down, 2 more to go. Let's do number 9. All right, I am going to show you the information here for number 9 because it was the same as number 8. I will strongly advise you that as you go through your assessments, make sure you go back if it doesn't give it to you a second time to get the base information. Just like in reading, right? We always go back to the passage. In math, go back to the problem, okay? So I plugged it in here again. If shoppers enter a store at an average rate of R, shoppers per minute, and each stays in the store for an average time of T minutes, the average number of shoppers in the store N at any one time is given by the formula N equals R times T. This relationship is known as Little's Law. The owner of the Good Deal store estimates that during business hours, an average of 3 shoppers per minute enter the store, and that each of them stays an average of 15 minutes. The store owner uses Little's Law to estimate that there are 45 shoppers in the store at any time. Okay, now I read that a little fast only because we've already talked about it, but I just want to keep that N equals RT in your mind. Okay, number 9. Let me see if I can, good. I can show both of them at the same time. All right, the owner of the Good Deal store opens a new store across town. For the new store, the owner estimates that during business hours, an average of 90 shoppers per hour enter the store, and each of them stays an average of 12 minutes. The average number of shoppers in the store at any time is what percent less than the average number of shoppers in the original store at any time? Now, I do want you to note, I want you to ignore the percent symbol when entering your answer. For example, if it's 42.1%, you're just going to enter 42.1. And it's vitally important that you do pay attention to those little instructions, especially when it's a typing section of the SAT. Okay, I want you to read over that again. I want to pause, let you think through the process. How can we solve this? again, it's more mental of figuring out where numbers go than the actual calculation component, okay? All right, take a moment. I'm gonna pause. All right, welcome back. If you took a break. If not, let's keep going. So we have some information to digest. First, we have, according to the original information, and I did scroll up, let me scroll back down. So according to the original information, the estimated average number of shoppers in the original store time represented by N is 45, okay? So if N is 45, in the question, it states that the new store, the manager said, estimates that it's an average of 90 shoppers per hour, okay? Now remember that hour is 60 minutes, so we need to change that. So 90 shoppers for 60 minutes. If you divide that, 90 divided by 60, you'll get 1.5, okay? So, and I just did that mentally, but okay, so 90 divided by 60, we did this earlier. 90 per hour divided by 60 is going to give us 1.5 shoppers per minute. Again, you do need to convert. There we go. Okay, so 1.5 shoppers per minute. And that's going to represent our R. The manager also estimates that each shopper stays in the store for an average of 12 minutes, which is our T. Okay, so R is going to be 1.5. T is going to be 12. And there was no calculation needed there, right? So that information came directly from our problem. Here we go. All right, each of them stays an average of 12 minutes. There we go. That's the time. Okay, and it did underline hours. So if you see anything underlined or boldface print, or italicized, anything that the SAT test kind of makes you think or catches your eye, definitely important to think about. Okay, especially with time. All right, so we got our R, we got our T, we're looking for our N. So let's do some calculations real quick. All right, so we're gonna do, N is gonna be same formula, right? According to the problem, R times T. Calculators, please get that out. Calculate this and let's see what you get. All right, I didn't pause the video, but didn't take too long to type that in, right? Everybody got 18? Got that? Yay, awesome. Now, the question asks for you to give the percent less than the original store, right? So if we have 18 shoppers at any given time, let me put 18 shoppers. And this is the new store. Let's go look at that, or recall the old store. Remember the old store, it was 45. Okay, so let's take that away and divide it by, that's the change. Change over the original. And then, oh, and don't forget we're doing percent. So let's throw that in at the same time. That's fine. How do we change this number to a percent? All you have to do is multiply by 100. All right, so then you get 60. But, Miss, oh, I'm so used to writing the percent symbol, but it says you do not need to write the percent symbol. So your final answer is just 60. I should have paused again for you to use your calculator. Okay, so make sure you have that before we move on. Go ahead, check out your calculator. Make sure you can calculate all those correctly. All right, good deal. All right, so it's 60% less than the average number of shoppers in the original store in town. Okay, let's move on to number 10. So we have already done 4. Number 10 is going to be our last one of this section of the most complex, hardest problems that you may see on the SAT. And then we can take a mental break. All right, number 10 coming right up. All righty. Now, before we move on to the last one, I did want to point out that this is a percent less problem. And what's important to note about it is, remember, he had an old store, a new store. The new store, the members, the shoppers are spending less time because they're moving much faster through, right? So the average time in the first store was longer than the new store. The original store operates slower than the new store. But that makes sense, right? In business world, you're thinking about when you go to a store that's been around for a longer time, it may take a little longer to get through because the new store most likely has faster equipment. It most likely has more workers, right? Because it's newer. People are moving a lot faster. And usually the older store may be more comfort zone and they don't have as many employees. So they kind of move around comfortably. And then the new store is like, get them through, get them through. So there you go. That's why usually a newer store moves a little bit faster pace than, especially when it comes to checking out customers, because they have so many customers, right? So they want to make sure, since they have more customers, they got to get them in, get them out. All right. So that's a real world connection to the 8 and 9 problem. Let's do number 10. All right. Number 10. In an XY plane, the point PR lies on the line with equation y equals x plus b, where b is a constant. The point with coordinates 2p, 5r lies on the line with the equation y equals 2x plus b. If p is not equal to 0, what is the value of r over p? And that is important. P cannot be 0 because fractions do not like denominators of 0, right? They're undefined. So we cannot have 0 in the denominator. All right, read through this one more time and then we will digest it together. You can pause here. All righty. I hope you took time to read through that so we can figure out what in the world are we supposed to do here, Miss Laval? I know, I get it. Okay, let's talk through it. So first, we have our XY plane. Now we have a point PR, right? So we're given PR. Here we go. And PR is going to lie on y equals x plus b. B is your constant, right? And we know that because we're familiar with lines. Now, with that being true, we can substitute, since we know the point, right? We can substitute. How about I write the original? That way you'll know why I'm substituting x plus b. And we're going to substitute in PR. So let's substitute PR, and we're going to get, if P is your X and R is your Y, then you're going to get R equals P plus B. And we're solving for our constant B. So we can also say B equals R minus P. Okay. Got that? I'm giving you some think time and some right time instead of pausing. Y equals X plus B, right? We're familiar with that, like if you're thinking mx plus b, so x plus b. And then we have our point, our x and our y. So if p is x and r is y, then we just substitute them in. Let me do another arrow. Substitute them in. And you have two ways to write that, okay? Now, similar to this, and I'll change color. Similar to that, we now have a way to look at 2p for x, 5r for y, and that lies on the line y equals 2x plus b. So we're going to do the same thing. This time our equation is y is going to be equal to 2x plus b. And we're going to substitute it in. Let's substitute the point 2p, 5r. What does that give me? Ooh. Let's see. Substitute that in. See what it gives you. 2p is your x, 5r is your y. You can pause if you want to substitute it in. on your own, and then let's see what we get. So we got 5r, 2 times x, which is 2p, plus b, simplify that, and then let's solve for b. So b would be equal to 5r minus 4p. All you do is isolate. So I'm subtracting 4p from both sides. And I just rewrote it. Equivalencies means you can write it a equals b, b equals a, same thing. Okay, so now that we have the constants rewritten, right? We can set the two equations equal to b equal to each other and then simplify because we have, let's see, I used to be able to draw shapes. All right, so let's do it this way. I'm trying to make sure you see what I'm talking about. We have b is equal to rp, and we have b is equal to 5r minus 4p. Well, we can just set b equal to b, right? Make sense? Right? Identity makes sense? All right, so let's do that. So we're gonna do, and I'm just gonna change it to black altogether. All right, so it doesn't look like it's the same. All right, so r minus p is equal to 5r minus 4p. A little more calculations than last time, right? All right, well, now we just need to combine. But remember now, we're trying to solve for, what was it? Scroll back up. We want to find the value of r over p. Okay, good. So let's solve, let's combine. Let's see. Let's make my, let's move that over because I'm trying to make sure my variables are positive. So here's what I'm gonna do. Normally I do it in my head, but I better show you. Let's add 4p to both sides. And at the same time, I'm gonna subtract 1r from both sides, okay? I'm gonna put a 1 here just so you can see that, right? So when I do all of that, if I confuse you because I did it both together, on your paper, I want you to do it separately, okay? So I want you to do move the p's and then move the r's, or move the r's, then move the p's. I hope that makes sense. It should. I just don't want you to do it together if you're not ready. Okay, so these cancel, and I'm left with, that's like a -1, right? So I have 3p here, and then these cancel. 5 minus 1 is going to give me 4r, okay? And remember I said, which one was top? Which one's in your numerator? R over P. Okay, so since we're looking for R over P, we're going to divide which side? Let's hope you said here. And here. Okay, let's move that over. So now we have R over P. Oh no, we still have that 4 to get rid of, right? We're not done. Almost. Last step, how do I get rid of this 4? In the numerator, right? So I just divide it out. All right, divide both sides. If I did this, visually, I don't like it, but it at least lets you see that you're dividing by 4. So 3/4 is equal to R over P. Find an answer. Let's see what that's up there. Make sure if it's right, it's definitely going to be there. All right, that is B. And if at any point in time, if I scroll down too fast, please just rewind and pause. Please pause me as much as you need to. All right, so let's talk about our answer options because we have a few and you know there's always a flip. Now, 4/3 is an option and then 2/5 or 5/2. So we know that there's a trick in there somewhere. Let's see. If you pick choices A and D, then you probably incorrectly form your answer from your coefficients. So that would be where we put in 2P and 5R, okay? Something went wrong in that step. I'm not sure what, but you can look back at it and you can figure it out. If you pick choice C, then you would have confused your R and your P. All right, so you flipped it. All right. Now I will say that I'll show you my work. Can I minimize it? There we go. Because this one had a lot of math in it. But I do want you to note that even though it had a lot of math, you didn't really need the calculator, right? All of this stuff was basic stuff. So we didn't have to use the calculator, even though it was a little more complex in the steps. Right? So the numbers were nice and friendly. So as you go through your SAT, remember we talked about there's a beginning that has no calculator permitted, and then the second half you can actually use a calculator. Even though your calculator is permitted, if you don't need it, then don't use it. It'll slow you down. But if you are a little nervous, which I can understand because you're on the time constraints, right? If you just need to double check yourself, then by all means feel free. Since this one only asks for a fraction solution, it did not give you a decimal, though this is a terminating decimal. Since it did not give you one, you didn't have to convert anything. All right, excellent work. When we come back, we'll get to the next question. This is it for part 2, day 2 of your Upward Bound STEM session. I'm gonna stop my share. There we go. All righty, thank you so much. I hope you have learned a lot today. We definitely covered some hard topics, which again, I told you this is a challenging summer. Like it's like, okay, let's get in the nitty gritty and what's difficult. And please keep in mind that this is if you are trying to get in that 500 plus math section. You really could push it to 600 plus on your math section. So this is a higher thinking, complex problems. If you're in the lower end of the assessment, especially if you're just starting out, please make sure you take my advice. Use Khan Academy. It's excellent. And it'll also help you prepare to practice, right? And also make sure you take the practice test to kind of see where you are if you haven't gotten the score yet. The most important part of this, especially with me teaching you the most challenging, is that you're ready for it. So if you're there, congratulations, hang in there. I know it's a little challenging, but that's what I'm here for. If you need any tutoring, by all means, see your Upward Bound director or mentor and let them know I am available to you. Email me alleducationalservices@gmail.com or email me via Midlands Tech AULJ @midlandstech.edu. I will see you guys soon. Make sure you visit the website and sign up for your tutoring session. And I will see you for your day 3 soon. Thank you. See you next time.